Hello everyone. In our last video we discussed about asymptotic notations. We discussed about big order, big omega and big theta notations. Now in our today's video we are going to discuss one of the very important topic, that is the recurrence equation. If we have a recurrence equation, then how we can solve recurrence equation to find the time complexity, that we will discuss in our today's video. We have certain methods to find the solution of any recurrence equation, and out of this method we will discuss the first method, that is our substitution method, in our today's video. So let us start our today's video on recurrence equation. First of all, what is recurrence equation? The recurrence equation is the equation that defines a sequence recursively. The normal form of any recurrence equation is t of n is equal to n into t of n minus 1 for every value of n which is greater than or is equal to 1. When the value of n is equal to 0, then t of 0 is equal to 1. This is the normal form of any recurrence equation, right? So if you want to read this recurrence equation, we can read that if the value of n is greater than or is equal to 1, for example n is equal to 1, 2, 3, 4 or any value of n which is greater than or is equal to 1, then your function will return n into t of n minus 1. This is the recursion because this function calls itself continuously for the different value of n. When the value of n is equal to 0, at that time your function t of 0 will return 1 as an answer, right? So this is the normal form of any recurrence equation. Now the question is how we can get a recurrence equation from any algorithm or from any program, right? So for example, one algorithm given, if you want to generate recurrence equation of the algorithm, at that time one thing you need to return, that in your algorithm, in your program, if we are using recursion function, a recursion function is nothing but function call itself. If we are using recursion function, at that time we can generate recurrence equation. Just take one example. Suppose find factorial of any number in C using recursion. I hope you know very well how to find factorial of any given number by using recursion in our C language. So just take one example so that you can easily understand how to generate recurrence from the algorithm, right? So for example, this is the program to find the factorial of given number using recursion, and recursion is nothing but function call itself. Suppose in this C programming we are declaring two variable n and answer. Then after we are getting one value from the user, so use scanf to get the value from the user. Then we are calling one function. The name of the function is fact. In that we are passing n as a argument. So when we call this function, at that time your control will jump outside the main program, outside the main function, and will jump on factorial function. Inside the body of the function, we have to write something so that your function call itself continuously for with different condition. So the first condition is if the value of n is greater than or is equal to 1, your function will return n into fact n minus 1. Right? So this is known as recursion. Here function call itself, your function will call itself with the different value of n, that is a reduced value of n. First time the value of n is equal to, for example, 4, then this function will call same function again, but the value of n minus 1, that is 4 minus 1, 3. Right? Again we'll jump on the fact function, again we'll check whether this value of n is greater than or is equal to 1. If yes, then we'll call same function with the reduced value of n. So first time it was 4, then after it was 3, then after 2, then after 1, and then after 1 minus 1, 0. When the value of n is equal to 0, at that time this condition is false, right? So we'll jump on outside the if statement, or we'll jump on else part. In else part we'll return 1 as the answer, right? So now this is the simple program to find the factorial of given number using a recursion function. For this algorithm, for this program, if you want to write a recurrence equation, then we can write like this. Our name of the function is fact. So fact of n, in that we are passing n as the argument. So fact of n is equal to n into fact n minus 1 if the value of n is greater than or is equal to 1. So we can write fact of n is equal to n into fact n minus 1 for every value of n which is greater than or is equal to 1. If the value of n is equal to 0, so we can write fact of 0, then we'll return 1. So when the value of n is equal to 0, we'll return 1. So we can write fact of 0 is equal to 1. Now in place of fact, if we write capital T, suppose, then we can say it is a T of n is equal to n into T of n minus 1 for n greater than or is equal to 1, and T of 0 is equal to 1. So this is our recurrence equation. So we previously discussed this recurrence equation is a common form of any recurrence equation. So in this way we can generate recurrence equation from any recursion function, right? So I hope you understood how to get the recurrence equation from any algorithm, from any program. Now suppose we have one recurrence equation, then how we can find the time complexity based on this recurrence equation. If you want to find the time complexity of this algorithm using this recurrence equation, then how we can find? For that we have to solve this recurrence equation. To solve the recurrence equation, we have certain methods. Suppose we have one recurrence equation. If you want to solve this recurrence equation, then we have basically two methods. One is substitution method and second one is master method. Both the methods are very much important to find the solution of any recurrence equation, right? So first, substitution method itself has a two part. One is forward substitution method. You can use forward substitution method to find the solution, or you can use backward substitution method to find the solution. In our today's video, we will discuss our first method, that is substitution method. In that we will discuss both the method forward substitution method with one example and backward with one example. And in our next video we will discuss our master method, right? So let us start our first method, that is substitution method, to find the solution of any recurrence equation. So as we discussed, we have two methods. One is forward and second one is backward. So let us discuss first forward substitution method to find the solution of any recurrence equation. As per this forward substitution method, this method makes use of an initial condition in the initial term and the value for the next term is generated, and so that this method is known as forward substitution method, because we are using initial condition which is available in our initial term, and using this initial condition we can generate next term. But how many times we need to generate next term? This process is continued until some formula is guessed. This method is known as forward substitution method. So let us discuss with one example so that you can easily understand. Suppose one recurrence equation given in your examination. This kind of example will be given in your examination. So try to understand how to solve any recurrence equation by using forward substitution method. One recurrence equation will be given in initial term and one initial condition will be given. So for example, our term is T of n is equal to T of n minus 1 plus n, and the initial condition T of 0 is equal to 0. Now solve this recurrence equation. This recurrence equation is recurrence equation of any algorithm. Now solve this recurrence equation and find the time complexity. So as we discussed, as per the forward substitution method, we have to use initial condition to generate our next term. So use our initial condition T of 0 is equal to 0. So let us start how to solve a recurrence equation by using forward substitution method. Now this is our first term, that is initial term T of n is equal to T of n minus 1 plus n. It is already given. Now put the value of n starting from 1. If the value of n is equal to 1, then we can write T of 1 is equal to, here value of n is equal to 1, so that T of 1 is equal to T of 1 minus 1, that is T of 0 plus 1, right? So as per our substitution method, forward substitution method, we have to use initial condition. Our initial condition t of 0 is equal to 0. So put this value t of 0 is equal to 0 in this formula. So t of 0 is equal to 0 plus 1 is equal to 1. Right? So when the value of n is equal to 1, at that time we can get answer, that is 1. Now check with the value of n is equal to 2. If the value of n is equal to 2, then t of 2 is equal to t of 2 minus 1, that is t of 1 plus 2. So t of 1 plus 2. So we have already value of t of 1. T of 1 is equal to 1. So put this value here, t of 1 is equal to 1 plus 2 is equal to 3. So when the value of n is equal to 2, at that time we are getting answer 3. Now put the value of n is equal to 3, then we can get t of 3 is equal to t of 3 minus 1, that is t of 2 plus 3. So previously we have a value of t of 2 is equal to 3. So put this value here, t of 2 is equal to 3 plus 3 is equal to 6. So simply we can say when the value of n is equal to 3, at that time we are getting answer, that is 6. In this way you can find for n is equal to 4, n is equal to 5, n is equal to 6 until you guess one formula. But here based on this 3 value we can also guess some formula. When the value of n is equal to 1, at that time your answer is 1. When the value of n is equal to 2, at that time your answer is 3. When the value of n is equal to 3, at that time your answer is 6. So we can guess one formula, t of n is equal to n into n plus 1 divided by 2. Both are equal. Because in this t of n is equal to t of n into n plus 1 divided by 2, in this equation if we put the value of n is equal to 1, we can get same answer 1. In this equation if we put the value of n is equal to 2, we can get 3 as answer. In this equation if we put the value of n is equal to 3, then we can get 6 as answer. Let's take one example. Suppose in this formula, that is n into n plus 1 divided by 2. Now put the value of n is equal to 1 in this formula. If the value of n is equal to 1, then t of 1 is equal to 1 into 1 plus 1 divided by 2. 1 into 1 plus 1 divided by 2. So that 2 divided by 2 is equal to 1. In our recurrence equation, when the value of n is equal to 1, your answer is 1. In this our formula, when the value of n is equal to 1, our answer is 1. Likewise, check the value of n is equal to 2, then 2 into 2 plus 1 divided by 2. So 2 into 2 plus 1, that is 3. 3 into 2 is equal to 6. 6 divided by 2 is equal to 3. So here when the value of n is equal to 2, at that time we are getting 3. Here also we are getting 3. Now check for the n is equal to 3, then we can say 3 into 3 plus 1 divided by 2. 3 into 3 plus 1 divided by 2, so that 3 into 4, that is 12. 12 divided by 2 is equal to 6. Here when we put the value of n is equal to 3, at that time we are getting 6. Here also we are getting 6. You can check any value of n, like n is equal to 4, n is equal to 5. These both are equal. So from this recurrence equation we can guess that this is also equivalent. So we can write t of n is equal to n into n plus 1 divided by 2 in place of this recurrence equation. Now solve this equation, then we can write n square divided by 2 plus n divided by 2. Right? Now out of these two term, n square divided by 2 plus n divided by 2, we have to identify which has the highest power. So our first term n square divided by 2 has the highest power. Here the power is 2, here the power is 1, so that this term has the highest power. Remove constant. So here the constant is 1 by 2, so remove 1 by 2, we have now n square only. So the time complexity of this algorithm is t of n is equal to order of n square. So this is all about what is a forward substitution method and how to solve any recurrence equation by using forward substitution method. Now our next method, that is a backward substitution method. So let us discuss what is backward substitution method with example. As per the backward substitution method, we have to substitute backward values until we derive some formula. So we can say in this method backward values are substituted recursively in order to derive some formula. So in our previous method, that is a forward substitution method, we are using initial condition to get the next value, but here we have to substitute backward value until we get some formula, right? So let us discuss with one example so that you can easily understand what is backward substitution method, or how we can solve any recurrence equation by using backward substitution method. So for example, we have one recurrence equation T of n is equal to T of n minus 1 plus 1, and the initial condition is T of 0 is equal to 0. Find the big O notation from this recurrence equation by using backward substitution method. So let us solve this recurrence equation by using backward substitution method. So as we discuss in backward substitution method, we have to substitute backward value until we get some formula, right? So our initial term in this case given is T of n is equal to T of n minus 1 plus 1. This is our equation number 1, and it is already given. Now we have to find the backward value. The value of T of n is T of n, suppose, and already given. We have to identify backward of T of n, that is T of n minus 1, right? So if you want to get a backward value of T of n, then we have to substitute n with n minus 1 so that we can get value of T of n minus 1. So replace n with n minus 1. So once we replace n with n minus 1 in this equation number 1, then we can get T of n minus 1 is equal to T of n minus 1 minus 1 plus 1. It means that T of n minus 1 is equal to T of n minus 2 plus 1, right? So we can get T of n minus 1 is equal to T of n minus 2 plus 1. Now consider this is our equation number 2. Now we have value of T of n minus 1. We can put this value T of n minus 2 plus 1 in our equation number 1 in place of T of n minus 1. So put this T of n minus 1 value in our equation number 1. So putting equation number 2 in our equation number 1, then we can get T of n is equal to, see, in this place T of n minus 1, we can write T of n minus 2 plus 1. So T of n minus 2 plus 1 plus 1, so is equal to 2. So we can get T of n is equal to T of n minus 2 plus 2. This is our equation number 3. Again I am repeating, we have to find this is our initial term given, and we have to find the backward value of T of n, that is our T of n minus 1. So we have to replace n with n minus 1. So once we replace n with n minus 1, then we can get T of n minus 1 is equal to T of n minus 2 plus 1. So now we have value of T of n minus 1 that we can put in our equation number 1, that is T of n is equal to T of n minus 2 plus 2. So this is our equation number 3. Right? Likewise, we have to replace n with n minus 2. Here we have replaced n with n minus 1. Now again find the backward of backward value, that is we have to replace n with n minus 2. So replace n with n minus 2 in our equation number 1. So when we put n minus 2 in place of n, then here we can get T of n minus 2 is equal to T of n minus 2 minus 1. So it will be T of n minus 3 plus 1. Then we can get next equation, that is T of n minus 2 is equal to T of n minus 3 plus 1. This is our equation number 4. So same way, here we have a value of T of n minus 2. This T of n minus 2 value we can put in our equation number 3. In place of T of n minus 2, we can write T of n minus 3 plus 1. So putting value of equation number 4 into equation number 3, then we can get a new equation, that is T of n minus 3 plus 3. Because we are putting this value T of n minus 3 plus 1 here, then T of n minus 3 plus 1 plus 2, so that we can get T of n minus 3 plus 3. Right? So likewise, put the value of replace n again with n minus 3, replace n with n minus 4, n minus 5. Every time we can get this kind of equation. Right? Now guess some formula from this answer, that is the first equation. Here we are getting t of n is equal to t of n minus 1 plus 1. Here we have a t of n is equal to t of n minus 2 plus 2. Here we are getting t of n is equal to t of n minus 3 plus 3. If we are getting next value, then we will definitely have a t of n is equal to t of n minus 4 plus 4. Then after t of n is equal to t of n minus 5 plus 5, like that. In place of this constant value, we can put one k constant value, suppose. Then the common form of this equation is, we can say t of n is equal to t of n minus k plus k. Right? Here the value of k is equal to 1, then 2, then after 3, then after 4, then after 5, like that. Right? Then the maximum value of k will be n. We can start from the 1, but maximum value of k will be n. So if we put the value of k is equal to n, suppose in this formula, if we put the value of k is equal to n, then we can get t of n is equal to t of n minus n, that is 0. So t of 0 plus k. So in place of k we are putting n. So t of 0 plus n. And initially the value of t of n, initial condition already given, t of 0 is equal to 0. So here in place of t of 0 we can put 0 there. So 0 plus n is equal to n. So we are getting answer n. So when we find the time complexity of n, then simply we can say the time complexity of this algorithm is t of n is equal to order of n, because there is no other term, so that we need to identify the highest power, but only one n is available, so that the time complexity of this algorithm is t of n is equal to order of n. This method is known as backward substitution method to solve any recurrence equation. Right? So we discussed the two methods. One is forward substitution method. In that we have to use initial condition to generate the next value until we guess the one formula. Then we discuss the backward substitution method. In that we have to substitute backward value until we guess the formula. So this is all about our today's video. In our next video, again we will continue with how to solve recurrence equation. As you know that in this video we discuss about only one method, that is a substitution method, forward substitution and backward substitution method. In our next video, one of the most important method we will discuss, that is a master method. This master method is also basically used to solve the recurrence equation. So this method will be discussed in our next video. So wait for the video. Thank you for watching. Thank you.